Thank you all for joining us at the 5:15 slot right before the Universal Studios party. Thank you for taking the opportunity to not go back to the hotel room and eat and everything beforehand. Thank you for joining us. I want to welcome you to Developing Connected Home Applications and Services for Windows Home Server. My name is CJ Soretto, and I want to start this conversation by apologizing. For the last year and a half since we released Windows Home Server, we've done a great job of marketing Windows Home Server to end users, people with multiple PCs in their home, broadband connections to their home. And we market this product as a solution for making those multi-PC problems they have a lot easier. The reason I'm apologizing is because we've not done a great job of talking to you, the developer community, about the potential that we see for Windows Home Server in the future and enabling what we believe to be a truly connected home. As I said, my name is CJ Soretto. I'm a senior program manager on the Windows Home Server team. I've been on the Windows Home Server team for just over 3 years now, so since it came out of incubation. And I'm joined today by Fabian Uza, my colleague, a program manager intern. And I have no data to go on, but I'm willing to bet he's the first intern to ever speak at PDC, so thank you for joining me today, Fabian. For the next 90 minutes, well, I'll hopefully speak for only 75 minutes, we're going to give you a brief overview of what Windows Home Server is. We'll show you some proof of concept demos that we've cooked up that we think are pretty cool to kind of inspire you. And then I'm going to dig into some of the Windows Home Server specific development tools that you can use, give a little guidance around that. And then hopefully we'll wrap with Q&A with 15 minutes to spare, and you guys can badger us with all of your fun questions, which I will try my best with Fabian's help to answer. So what is Windows Home Server? Well, you're probably all familiar with Windows Server 2008, Exchange Server. These are our corporate and enterprise class server products. They serve organizations with large numbers of computers, large numbers of employees, and I would be willing to guess large IT staffs. You might not be familiar with our Windows Server solution products. So we have Small Business Server and Essential Business Server. These are marketed at small to mid-sized businesses. They have, fewer PCs, fewer employees, and if they're lucky, they have a full-time IT staff. It might be a guy in the back room doing it in his spare time. In 2007, we released Windows Home Server, a new solution product targeted specifically at the home. And the home is very different from all of these previous ventures that we've undertaken. The home has a family unit, a small number of users. They're starting to get more and more PCs under their belt, and they're starting to have problems with managing those PCs. Unlike the other organizations, they don't have an IT staff. In fact, in your homes, I'm willing to bet that each one of you is probably the IT staff of one. And my guess is that you don't really enjoy administering your server, or administering your PCs, much less adding another thing to your home to administer like a server. And so we've built Windows Home Server as a solution product to try to solve your problems and make life easier. Now, the interesting thing that I like to show on this slide is the potential market for this product. There's less than 20,000 corporations and enterprises as defined on this slide in the world. There's over 60 million multi-PC broadband connected households. So even though it's the cheapest product, it's also one that we see a huge amount of growth for, and we see it enabling a lot of cool scenarios in the home that we hope to talk about today. Home servers are reliable, always available nodes in your home network for running on-premises services. You've heard a lot today about services that run in the cloud, or yesterday and today, about services that run in the cloud. Windows Home Server is a place to run services in the home, and that includes services that ship with Windows Home Server, as well as services that will be developed by people like yourselves. Home Server is the brain, or we envision it to be the brain of a connected home, where software, devices, PCs work together to deliver seamless experiences to our users. And as I said before, Home Server is a seamless device that Home Server is a device that brings all the computers in your house together in a way that is seamless, that you can set and forget, just tuck it away in a closet and not have to worry about it. Now, obviously, I've talked about home server as a platform for the connected home. But we have to do something with the product in order to get it into the households, right? People aren't going to buy this just to buy a platform. So we specifically built the product to protect users' data. We built it to help them organize their data so that if you have a lot of computers, you can centrally store that data so that you can always find the latest version of a file. We built it so that it connects your computers when they're at home and away. So even if you're away from home, you can reach back into your home server to retrieve your data that you may have left. And we built it to grow with our customers. Now that applies to storage. If you're familiar with the product, you can plug multiple hard drives in and the server just gets bigger. But that also applies to on-premises services. So users can add new services and capabilities to their home server to give their homes more capabilities. Now, I said 60+ million possible homes, broadband-connected multi-PC homes today. We see a lot of potential for Windows Home Server. This slide just gives you a really quick view of how analysts see home servers in the market. You can look at the data. It's all a bunch of hockey sticks. But analysts generally agree that by 2010, we're going to break the 1 million home server mark. And I talked a lot about what a connected home is. Well, a connected home is just a home where there's a lot of devices and a lot of services interacting with each other to deliver scenarios to end users. This slide gives you a brief outline of some of the scenarios that we, Microsoft, envision in a connected home. It's by no means a complete list. It's a taxonomy that we use to think about. Home server has features that fit into some of these scenario areas, as I mentioned before. But I want to just target in on one, which is the third-party enthusiast platform. We built home server so that you would extend it. We want you to add capabilities to people's homes that they never imagined were possible. And today, I'm going to hand over this conversation to my colleague Fabian, who's going to show you one glimpse of a scenario that we think would be pretty cool that demonstrates the power of Windows Home Server. Fabian.
Thank you, CJ. Thank you, CJ.
Sure.
Can you? Thank you. All right. Yeah. I'm here at PDC. Wow. Feels great. Really, really great. I just arrived the last for about 11 weeks from Germany. So please, my language is not that perfect. And I spent my time being a program manager for Windows Home Server. And I really like to say Windows Home Server is one of the most amazing products I've ever worked with. Because the way we are going to live in our homes is about to change in the future. And so does the way we will experience our software and services. And Windows Home Server is Microsoft's platform for a connected home. And that makes it easy to understand that everybody who's going to build his applications on top of Windows Home Server, or at least makes it aware of Windows Home Server, could generate himself a huge number of opportunities. So in order to set up our demo today, we worked with our friends from Lagotech. They offered us some help and provided us some really cool devices you're going to see today. And I would like just to show you a few of them, because I'm in the mood of watching a DVD. So let's go over in my living room and just start my Windows Media Center. CJ, can you assist me, which is the Media Center? All right. Thanks very much. There we are. So I just switched to, or I just launched my Windows Media Center application. I go to the application that we wrote that's basically an application that plays a DVD. So I already inserted the DVD, and oh, my house actually knows.
Living in such inhospitable places, extremophile.
Thanks very much. And my house actually knows my preferences. So it knows it might be a good idea to close the blinds to not get any reflections on my screen. And as we go on with having an impression of what a connected home means, it does not mean to have just a button to press and something happens. It is something that is connected. Services that you set once, and your house is smart enough to remember them, and to apply them at the right point. So right now, I believe it's a little bit cold in here. So when I watch my movie and all those stuff, so I maybe want to change my temperature in this room. And we believe that a connected home should have all the services available and at a place where it makes sense to have them available. And it depends on you, the developers, to make a decision where those points of where it makes sense to have them available are. For instance, I can go back and just have my thermostat controlled by my Windows Media Center, just because it's convenient. I'm just sitting in front of it. So I change the application and just have a look at my room temperature. So in a couple of seconds, we're connected to the thermostat, and we're connecting and connecting, and there we are. All right. You see the current temperature of this room is 72 degrees. And what I wanted to do is I want to heat the room because I feel a little cold. So let's give it a set point slightly above this room temperature. Now I hope you can see that the fireplace turns on. Thank you very much. That the fireplace turns on, and we're actually trying to heat the room. So when I wander through my house, I maybe experience or maybe see a room where actually the blinds are down, and I just want to make them go up. And to do so, I don't have a Windows Media Center right in front of me. And unfortunately, there's no touchscreen in my wall behind. So what am I going to do now? Oh, I'm carrying my Windows mobile phone with me. So all I need to do is to launch the application. This is the screen of my Windows mobile phone. And just press the button. As you can see, I just press the button, the blinds go up. And another idea is I just change the temperature with the Windows Media Center. Maybe it's a good idea to change the temperature with my mobile device. So all I need to do is to switch the application, go to the thermostat, can see the current temperature, need to refresh it. So we're currently heating to 74 degrees, but I would like to cool the room. To be honest, it's really hot on stage here, so I'm going to just give it a set point slightly below the current temperature. All right, should good. I just press the apply button, and as you can see, the fan turns on and the fireplace turns off. So, thank you. Thank you very much. So, what is actually behind the implementation model we used here? What is the role of Windows Home Server in that? Because it's a really essential one. You need to have a 24/7 availability of all the services in your room. And that's exactly what the Windows Home Server is meant to be. It's an always-on device, as CJ already told, and it is a reliable device. So what we do is we stand up a long-running service on Windows Home Server, and we stand up another, can we switch back to the PowerPoint? All right. I just give you a short overview of our network. We have the Windows Home Server in the very center of our slide. It means it is the brain of our home. So it is connected to a router, which is the basis of our home network. We have a development PC connected to it. This is the guy you saw the screen from my mobile device on. We're going to use it later to show you some code. And we have, of course, the Windows Media Center PC. You've already seen some media playing on it. And we have the smart devices we have. For instance, we have a thermostat. So now I'm going to, all right. So this is actually a board that controls fan and the heating or the fireplace. So connected to this board is a tiny temperature sensor. I'm just trying to show it to you like that. This is our tiny temperature sensor. and it measures temperature of the room and has a bunch of low voltage relays that I actually use to connect to a high voltage relay. This is, for instance, our high voltage relay, so it's nothing special. And we plug right in there the fireplace and the fan. And another very interesting or very important board is the shade control. I just put it on top here. I hope you can see that. It has, okay. It's basically a bunch of low voltage relays that enable us to set or to connect more than just one pair of, or just one shade. And we are going to use these devices because they are IP controlled. We can connect them directly to our home network. You might find that's more suitable for you or your company to have your own protocol stack, to have your own communication methods. We don't want to limit that with Windows Home Server. You should be free to decide by yourself what you want to have and how it should communicate together. Let me switch back to the slides. I want to show you how we actually implemented our solution. You can see the Windows Home Server as a central brain of our home. And what we did was we stand up two services. The first is a Windows service. That is the very brain of our house. It's a long-running service. It runs 24/7 and has all the logic we need to operate those devices. We have also a web service. So Windows Home Server is basically a Windows Server 2003. And you have, of course, an IIS running on Windows Home Server. So you have a predefined environment, and you can easily stand up web services, for instance. We use this web service to expose all the functionalities of my home in the home network. And in order to do so, we used .NET Remoting and just gave it a meaningful name and a TCP stack. And you're going to see this later if we go through the code. So every application that runs directly on Windows Home Server can leverage the Windows service directly. So for instance, the Windows Home Server admin console. CJ is going to tell you a little bit more about the admin console in the next couple of minutes. But all the devices you have seen are connected through the router to my home network and communicate to this web service. So my Windows Mobile, actually, it took longer to create the graphics than to write the actual web service code for it. And so my point is, it's really easy to develop for Windows Home Server because it's basically a Windows Server 2003. And right now, I'm just going to show you some lines of code and our implementation of, is that the right one? Yeah, and our implementation of the solution. So we open the solution folder, don't need this, and start. I don't want to live code from scratch because there are a lot of custom hardware-specific lines in our code. So I basically want to close all of these. We don't need that. All right. Let's have a look at our solution. So the first project you can find in our solution is the common library. The common library basically is it is a class library containing two interfaces. We need those two interfaces to enable the objects to be remotable. I'm going to show you a little bit later. The Windows Service project is actually the project you've seen, or that is actually the project that runs or creates the Windows Service you've seen on the previous slide. It contains two simple objects. It is one object that controls the blinds and one object that controls the fireplace or the HVAC itself, so all the heating, all the temperature detection, stuff like that. So let's have a quick look into the first object, the blinding controller object. In order to have it remotable, we need to have a few namespaces like .NET Remoting. These are custom DLLs we need to reference because of the communication protocol that's based on those specific hardware. And of course, if you want to have a remotable object, you need to implement Marshall by Ref object. But there's one problem. We talked about a 24/7 running device or 24/7 running service. And if you, for instance, just don't use Windows Server, if you just don't use your blinds or the Windows service itself for longer than 5 minutes, the remote object will time out. So what we did is basically we wrote a small override method that just returns null. I want to remember you, this is not a productive code. So you might think there are other possibilities to communicate with your long-running objects. This is basically an inspiration of how we did this and what does it. All right, now I'm missing a word. Okay, let's go on. Okay, so we have the two objects in our Windows service. On the home server itself, that is our little home server. So this guy is fanless. It is very energy efficient. What is a really, really important thing in the changing environment questions we need to think about. We need to rethink a few things. How do we live in our future homes? Do we really want to consume more energy, or do we want to try to save energy? And if you have a bunch of proprietary devices that are always on, maybe in your wall, maybe somewhere else, and each of them controls separate hardware devices in your home, develop or create services for shades separately, for HVAC controlling separately. All those devices are basically consuming energy. If you have a centralized device that is your brain, you can leverage a lot of implementation work and a lot of logic we already did because it's a Windows server. And CJ is going to tell you in a couple of minutes how you can leverage all the things we already have bundled in Windows Home Server. All right. The last project we have is, by the way, this is our, where is it? You took my mobile phone. Not a problem. All right. This is actually the project for the Windows mobile device. It's a really short Windows Forms application and just talks to a web service. It has the web service here, one web service for the blinds and one web service for the HVAC. And we have, of course, our web service project. So what do we need to actually start remoting? I believe many of you already worked with .NET remoting. It's nothing really new. So in order to run a web service, or in order to have a remotable object, we have already implemented the Marshall by Ref object and have this object remotable. So let's go and have a look into the. All right, there we go. Let's go and have a look into the service code. We have a couple of possibilities to use .NET remoting. We have, for instance, you can use an HTTP channel to promote this object. You can have an IPC channel or an TCP channel. In our case, we used a TCP channel and initialized the service as it starts by creating a new channel. We gave it a name, or we gave it a port that's most likely not used by any other application. And of course, we have two instances of our objects, one of the blinds, one of the HVAC controller, and we gave it a name and just publish or marshal those objects down to we just open the channels and just publish those objects. So in the web service, we need to consume those objects. We have our two web services. Let's have a short look into the blinds. And there we go. We have up here our blinding controller object. This is actually the interface we implemented in the common library, the first project I showed to you contains those interfaces. We use it as some kind of a contract that we make sure that every connection or that every method we offer is basically supported by each part of the TCP channel. So one side offers the object, publishes it, and the web service is the other side and consumes this object. In order to do so, we need to create a remoting connection. And we did something that seems to be a little bit stupid, because we call one of the methods without having a real need to do so. But that's not quite true, because when you instantiate a remote object, you don't necessarily have established a connection. You just set where to find this remote object. So this is actually the point where we create the connection. All right. So our interface basically is implemented in these few methods down here. You can see we have a method that makes the blinds go down. We have a method that makes the blinds go up. And of course, we can stop somewhere in between. So that is basically a short overview of what we did to implement this demo. I hope you can see that you should not be afraid to actually plug hardware into Windows Home Server, and that you shouldn't be afraid to have long-running services on Windows Home Server, because you can leverage a lot of investment you already took into creating your applications running on Windows Server operation systems. Another example might be, it's just another client. When you, for instance, think about all the consumers in your home, basically your family members, they want to have an easy and convenient method to maybe have access to a lot of services that your house or your home offers. So what we did is basically we wrote a small sidebar gadget. I'm quickly going to pack it. And, oops. All right. And I need to rename it like thermostat, and it is a gadget. All right. When I click on it, I can install this gadget on my client machine, and what I get is basically an Ajax implementation of connecting to my web service, getting my current temperature, and maybe change the set point to a higher temperature. And we should see that the fan stops and the fireplace starts working right now. There we go. So this is a really convenient method to just have another client in your home, available to all your family members. So I like to thank you for listening to me, and I like to hand over to CJ to give you some more advices of how to use the Windows Home Server console and some more deep dive visions. Thank you.
Thank you, Fabian. I hope that the demonstration you just saw makes it extremely obvious how we believe that how home services should be stood up in the home. What Fabian just showed you is that you can take all of your proprietary logic, stick it in one place on one device in the home, specifically the home server, and then expose all of the capabilities that your service offers as web services to all of the devices in your home. And then those devices can easily consume those web services. We think that using remoting and using web services and .NET remoting to communicate between a front-end web server and a core long-running service, which you run on Windows Home Server, is an excellent paradigm to use. Obviously, you're free to use anything else. So with that demonstration, let me quickly switch back to my slides here. I want to give you guys a little bit of guidance specific to Windows Home Server. Developing for Windows Home Server is developing for Windows Server 2003 with a very specific and known configuration. That makes it even easier than developing for Windows Server 2003 on its own. Specifically, Home Server has a single point of administration. We call that the Windows Home Server console. It's the application that the Home Server administrator uses to configure the server. So you don't have to worry about users going in behind your back and doing lots of different things that could potentially screw up your application. Windows Home Server is generally in a very standard network topology. A home network is a fairly standard thing, usually a bunch of computers behind a router. And Windows Home Server includes IIS, which is configured by default in a standard configuration. So when you're actually putting that web service up on Windows Home Server, you know exactly where you should place the service, how IIS is going to be configured, and that makes it easy to develop web services or websites on Windows Home Server. And lastly, since it is just Windows, it makes it super easy to leverage the existing investments you already have in Windows software. So if you have software that runs on a PC, you want to move it to Windows Home Server, it should be extremely straightforward. Now, I mentioned the Windows Home Server console. The Home Server console is the central administration point for Windows Home Server. And as such, if you're putting services on Home Server, you're clearly going to need a way to extend the console, and we built the Home Server console in an extendable way. Extending the console comes down to three interfaces: iConsole tab, iSettings tab, and iConsole services. I'm actually, rather than talk about them, I simply want to show you how to use them. Quickly switch back to our development machine here. Sorry, guys. Wrong button. There we go. Switch back to our dev machine. I'm just going to open up my little solution. And what you can see here is that we have a PC. It's connected to the Windows Home Server. I'm going to apologize very quickly. Moving an entire home network into a conference room can cause things to break. Little back of the magic configuration here. This is the Windows Home Server connector software installer. I'm just configuring this client to work with this Windows Home Server. All right. What we have here is a solution that implements an extension to the Windows Home Server console. Specifically, we've added a tab to the Windows Home Server console for controlling some of these home automation devices. You can see that here. The Home Server console ships with 4 tabs: the computers, users, shared folders, and storage tab. And we've added, as part of our demonstration, a new home automation tab. In this tab, you can see that we have the thermostat device and we have the blind controller. How do we do that? It's actually super straightforward. A tab in Windows Home Server is just a Windows Forms user control. And in this solution, what you can see is that we have a home automation tab file. And in that file, you can see here in the designer, we have the contents of that tab that you just saw. Now, rather than go through all of the code step by step, I'd like to show you how to create a new thing. So if you have a console tab, you may also want to have settings for your specific add-in, and we provide an affordance for that as well. You can extend the Windows Home Server console also by adding a new settings pane. So we ship a number of settings panes by default. You can add your own. We're quickly going to add a settings pane for the home automation project that we're doing here. To do that, I'm just going to add a user control. Windows Forms user control, and we'll call this Home Automation Settings tab. You can see that I have a very standard Windows Forms control here. I'm going to add to it from the toolbox, which I've managed to lose. There we are. Sorry about that. I'm going to just simply add a label. Got it. And we'll give that label some text. We'll say hello PDC. There we have it. And now we have to tell the home server console that when it loads our DLL, that it should actually load this user control. Doing that is also fairly straightforward. Now this solution that we're building here is just a class library solution. It results in a DLL. I'm going to open the home automation add-in file. I think of it as my main file. It contains all of the classes that the home server console will load. You can see here that we have a class called home server tab extender. It implements iConsole tab. What that means is that this class represents a tab in the console. To add a settings tab, I simply implement a class that will extend the iSettings tab interface. Settings tab. There we have it. And then I'm simply going to implement the iSettings tab interface. And iSettings tab, it requires me to implement a number of functions. I'll speak briefly about those. The first is the commit function. This is called by the console if the apply button is pressed in the console and the settings need to be applied. Since we're not actually having any settings in ours, we'll just return true. We also have a get help method. The get help method is called by the console if help is pressed while my tab is in focus. Again, I'm just going to return true since we aren't going to write any help here on stage today. We need to return a GUID that uniquely identifies our settings tab. This is important if you, from one tab in the main console or a settings tab, want to open another tab by name. So every tab needs to be uniquely identifiable. We're just going to return a new GUID. And I'll just simply use the toolbar to get myself a new GUID. There we go. I obviously need to return the user control that represents my settings tab, so I'll do that quickly. Return control. And obviously I'll need a member variable for that. There we go. Sorry, guys. And we'll need to return an image for the tab. We have an image in our library already. It's here in the resources. So we'll just access our namespace. tab. Hit return. Tab. There we go. We'll need to return some text. This is the name of the tab that will appear. And finally, we're going to need to write a quick constructor here for our object. And the constructor is very specific. In order for the home server console to load this object out of our DLL, it has to have a specific identifier, and that is an integer indicating the width of the object, one for the height, and very importantly, a reference to an iConsole services object, which I'll mention a little bit more in just a moment. And in this, what we will do is set our control and we will pass to that a width and a height, so that our control knows how to size itself. Need to give that a type, obviously. Okay, and now obviously, since we never defined a constructor for the home automation add-in, or the home automation settings tab, we'll need to do that quickly. So here, we'll get the code behind on this tab. We'll change the method here. And we'll do our set bounds so that we set our control correctly. There we have it. I believe I still have an error here, and I have to admit I need it. There we have it. Two lines. Sweet. There we have it. I've never written code on stage before, and I have to admit, being a program manager, I've practiced this a million times, and in the lights, it is a little tough, let me tell you. So what we'll do is grab our little solution here. We have a thermostat tab, bin file. We'll take our home server console tab, DLL, and deploying this to Windows Home Server is fairly straightforward. Obviously, the installer would be doing this for you, but I'll just cheat while we're here on stage. And I will drop the file into the home server program files folder on the Windows Home Server. You can see that all of the home server DLLs need all of the DLLs to be opened by the admin console required to be named home server console tab dot something dot DLL. You can choose what that middle part is. We'll copy the existing file on top. I'll do a really quick trick here. If you're ever a developer for home server, you should know that you can reset the Windows Home Server console at any time. That stops the process on the server so that you can actually do things like copy files. And then we'll restart the Windows Home Server console. And in just a moment, we should have our tab displayed in the server settings. There we go, Home Automation Hello PDC. Now, if a senior program manager, which means I don't write a line of code, can do this, this should be extremely straightforward to you guys. I'm not a WinForms developer. I'm not a developer at all. But if I can make Hello PDC show up in the Windows Home Server console, any single one of you can make a lot more exciting things show up in the Windows Home Server console. So it should be really obvious. If you know WinForms, if you know .NET programming, you know how to extend the Home Server console and make any software you have running on the home server work in a headless environment. So we'll switch back to slides really quickly. All right. You can make anything you want show up. What should you make actually appear in the Windows Home Server console? As you saw, it's WinForms. We built the Home Server console as a place for the home network administrator to actually go and change settings for the server. If you have a setting that needs to be configured for your service that's running on the server, the home server is a great place to do that. And here we've just mocked up an example where an add-in is configuring websites on the IIS built into the home server. This is an awesome example of a correct usage. Now, you might decide, oh, I could build anything I wanted to in Windows Home Server console. I might build an RSS reader. Now, we actually think that's an improper usage, and let me tell you why. Home server has a set and forget simplicity. We want the administrator to never have to think about this box, right? If they're visiting the console, they're configuring something about their home server, their home network, and that means that should be an extremely rare operation. We don't want to encourage users to actually use the home server console to actually reach applications. Now, if you're a developer and you've added something to the home server console and the only thing you put in this tab is a setting, consider not having a tab at all. The Windows Home Server console doesn't require that you have a main level tab. You can have a settings tab, just like I just showed you, without having that main level tab. So here are some settings implemented directly in the settings tab. And so just to recap, don't use the console as a desktop. Use it only for configuration purposes. And don't host long-running applications in the console. As I just showed you, the console could be reset at any time. The console doesn't start when Windows Home Server starts. It's simply an administration UI. Do put your long-running code in a service that runs on the home server, and you can be sure that that code will be running reliably so that when it's ready for your users. Having talked a lot about the console, I want to switch quickly to notifications. Notifications are a home server specific way of alerting the home administrator when something is wrong, something they need to take action on. Notifications can originate from the server, or with a new addition to our SDK, they can also originate from the client. And you have to remember that notifications are user visible. What that means is that if we don't give you a free communication pathway between the clients and the servers, I'm sorry. If you send a notification through the pipeline, it's going to appear in the home server console and on every PC that's connected to the Windows Home Server to attempt to get the home server administrator's attention. To do that, you simply use the WHS info class. If I go back really quickly to my tab, there we are. If I go back really quickly to my tab, to my control, let's say I just want to add a quick button so that I can send a quick notification. I'll add a button. I'll write a little tiny bit of code behind, and all I need to do is reference the correct namespace first so that I get the right thing going on here. Using there we go. So now that I have the right namespace, I can do a super simple thing. I can call the WHS info class object. And now that I have that, info.addNotification. And a notification has a couple of things it needs to have. One is a unique identifier. This uniquely identifies the application to the system. So we'll give it a GUID. It's the safest thing to do. It requires a state. This tells us if this notification should appear as yellow or critical. I'm sorry, yellow, which is a warning, or red, which is critical. So we'll make this one a red one. It's an error. We need a header to tell the user a quick description of what's wrong. We'll just say danger, Will Robinson. And then you need a longer description. And a notification can have a couple of user actions. One is that you could invoke a help file. In this case, this notification won't do anything, so we won't have a help file. Or a notification can contain a URL that the user, a URL that will be launched from the notification. We'll just say no help file, no URL. Thank you, sir. There we go. We'll rebuild our solution really quickly. We'll kill the home server console, and we'll deploy that. We'll recopy our DLL one final time. There we go. We'll relaunch the console by typing the administration password for the server. And in just a moment, you'll be able to see that from the settings tab that we've created, we can send a notification. And that notification should be visible to every device inside of the home network. Unfortunately, that doesn't seem to be happening. All right, sorry about that. Thank you, Jerry. If anybody doesn't know Jerry, Jerry is the eminent knowledge base about Windows Home Server Admin Console and was the developer on the HP Media Smart UI for the HP Media Smart server. So if I'd done that and I'd set info, you would have seen that a notification appears here, the home server would become red, and in the icon so that the administrator would see that, and if they visited the home server health, they will have seen it here in the list of notifications. I won't make you guys wait for me to redeploy that. And finally, I want to mention a little bit about deploying a home server add-in. So if you decide to actually build an add-in for home server, you need to package that up so that the user can install it. To do that, you need to create a silent MSI. You need to include all of the services that you have for your add-in as well as the administration UI in that MSI. And then you need to instruct your users to place that MSI in the server software add-ins folder on their server. And then your users can manually install that add-in through the home server console through the home server console UI. And once your add-in is deployed on the home server, if you have client components, as we just showed you we did during our demonstration, we suggest that you place those client components in the software share on the home server. And that's a really easy way for all of the PCs inside of the house to be able to get to the client component software for your services that are running on the Windows home server. So I've talked a lot about home server specific development for the last couple minutes. I'd last like to posit that being aware of home server is super easy as well. So even if you don't feel like you have code that you want to run on the Windows home server, it still can be very helpful to be aware of the Windows home server's existence from any PC inside the house. You know that the Windows home server has a set of default shares, music, photos, and videos that are always there that you can count on. You know that if a home server exists in a home network, that all of the computers in the home that have the connector software installed are being backed up every single night to the Windows home server. And if you're one of those developers who runs a web service on a PC in the house, WebGuide's a really great example. You can probably name a number of others. You should expect that traffic on port 80 coming into the house is going to be directed at the Windows home server. We have a remote access feature that runs a website inside your house so that you can get into your house from anywhere in the world. So just be aware that port 80 is going to be taken up by the Windows home server. And we'll talk a little bit tomorrow morning about how you can use the home server as a secure web proxy if you're in the situation where you need to forward a port to your application running on a PC that is taken by the Windows home server. So to detect a Windows home server, if it's on the network, it's super easy. You just inspect the registry. You can take a look in local machine software, Microsoft Windows home server on any PC in the house. If you see the 2 keys version and backup enabled, you know that there is a home server on the network and that this PC has the home server connector installed. And if backup enabled is set to a non-zero value, you know that that PC is being backed up every night. And just a really quick example of why you might want to do that, if you're Windows OneCare, for instance, you'll look at that registry and you'll say, oh, that PC is already being backed up. I don't need to complain if the user isn't using my application to back up their data. I know their data is already safe. So finally, in recap, home server is a new product that we envision is going to power a connected home. A connected home is a place where there's many services, devices, and software collaborating together to give users seamless experiences inside their home. Home server is super easy to develop for because it's just Windows. And with the power of IIS built into the system, you can stand up web services on the home server that will allow any device in your home to use the services of the home server. And if you do that, and you stand them up as web services and you want to expose them outside the home, we'll show you how to do that during our talk tomorrow morning. And lastly, I just want to remind you, please architect your solution so that your long-running code is running on the server and that your user experience is running on the clients. Because if you imagine a connected home, if you have services in your home, you're going to want them from the right devices. So when you're building for home server, think about which devices need to consume the services that you have running on that server. Where does it make sense to place code? We chose to place it on a Windows mobile phone in a media center. It might make sense to write a Windows sidebar gadget. It might make sense to just stand up an HTML website on the server and use that as the interface. But just make sure that you're thinking about where you want to place that client code and how your users are going to use that service. And lastly, I just want to remind you that you can check out the developer guidelines, which is a white paper we've written. It recaps most of what I talked about today, and it gives you a little bit more in-depth conversation. And that supplements the Windows Home Server SDK, which you can find out on MSDN. So I'd like to say thank you for listening to us talk for the last 60, 70 minutes. There's an evaluation form which you can find at microsoftpdc.com. I'd really appreciate it if you'd fill that out and give us your feedback. And also this session will be available on the Microsoft PDC site if you want to point anybody to it in the future. And with that, I'm going to open the floor up for questions. So if you have some questions, please feel free to go to the microphone and give a shout.
Hello. I'll start off, TJ. Mike's not on, but what's this about a discount for a home server? I want to hear about it.
I don't know, Mark. Why don't you tell us?
Okay. My introduction, I'm the marketing guy for home server, and I can't resist but come up and give a pitch. Thanks to our friends at HP, we have a special discount on home server, so you can walk home, order one here at the show, special, $100 off, gets you to a net price of $399. So if there's any hesitation at getting a home server in your home, now's your chance. Come by and see me right after this, and I've got little coupon codes to give out to you. Thank you.
Yeah.
Talking about those nice devices on the table, we are talking about proprietary hardware with proprietary drivers, right?
Actually, these particular devices are IP devices. They are proprietary for sure. And then the proprietary driver, if you will, is a bit of software that's in the Windows service that we've written that knows how to talk to that device. And then from that point forward, it's exposed as a web service which any device inside of the home can talk to in a very standard way.
Yeah, my question was basically about Microsoft is not going to provide some kind of common API, like, for example, direct apps for home devices?
At this point, we don't have any plan to do so. We think that home automation is an awesome scenario, but we leave that up to the individual software developer to figure out how to do that. We don't have a framework for speaking to home automation devices today. We don't.
Okay, thank you.
Yep, for sure.
When's it going to be on MSDN?
What's that?
When's it going to be on MSDN?
The home server product itself? I believe it's coming soon. Yeah, it should be coming soon to MSDN very shortly. So if you're interested in checking out home server and developing for it, you absolutely can get it through MSDN in the coming weeks.
If you're desperate for a copy, whsisv@microsoft.com. Let us know what you're interested in building, and we'll hook up.
Just give me a check now.
Any other questions in the audience? Yes, sir.
The media center, you showed the code for the add-in and for the client. What about the media center piece? How do you develop that?
So the question was, how do we develop the Media Center add-in, and what about the code there? Media Center code is separated into two components. One of them is a UI description language, and then the second is a DLL, which is basically the code behind, if you will. So what we did was we implemented a very basic piece of UI in Media Center, as well as some code that could speak to the web service, and build a small MSI package that installs that bit of code into Media Center and makes that available through their interface.
Is it C# or is it something else?
Almost all code in Media Center is managed, and in this case it is C#, yes. At least the back-end code. The front-end description language is proprietary to Media Center. Yeah. Yeah, if you check out the SDK for Media Center, it'll describe clearly how to do that. And it's right up on MSDN. It's publicly available. When are we going to integrate Media Center and Windows Home Server is the question. We've heard that feedback loud and clear from our customers that they would be interested in a combined product. And while I can't speak about future plans, I can say that we are hearing the feedback and we're listening.
MSTV?
The question was, what's that?
What about MSTV? Any plan of linking that together with home service?
The question was linking MSTV and Windows Home Server. We don't have anything that we have to publicly talk about today, I'm sorry to say. Any other questions? All right. Well, thank you very much. Really appreciate it.